So I'm Mikhail. I'm product manager at Protocol Labs, and I'm working on the project called IPC, and also stands for Interplanetary Consensus. So let's talk about this presentation today. So I think interplanetary consensus is very important because it provides this feature of scalability to blockchains. And we will dive into the reasons why it's really important to have scalable blockchains and what it brings us to Web3 world. So what I will cover today is a little bit less technical, more like kind of like high-level philosophical content about what interplanetary consensus is, what feature it provides, and how it works. However, in addition to this, we will have a detailed walkthrough how to set up your own subnet. So my colleague right now are working to finalize the video, and we will be sharing very soon. I will collaborate with Rory or maybe somebody else to share it. And this will be like detailed coding video with command line parameters and all the interfaces and like configuration files that help you to get things going. Okay. So I will spend maybe 20 minutes, I think, on the actual content. Let's see how much actual time it will take, and ask questions in the chat. I will stop and answer them if they're relevant to the slide that I'm talking about. If not, we can use our 10 minutes in the end, and I will be happy to answer all the questions. I think Q&A is the best part. Okay. So a little bit about myself, like I am product manager at Protocol Labs. I used to work at Google before, and Dfinity, which is a company or organization behind Internet Computer that pursue kind of similar set of goals of making Web3 more powerful. Okay, so let's go to the next slide. So I wanted to start with the question of scalability and like what is the limitations of existing blockchains. And like each blockchain claims different numbers, and like for Solana, for example, they claim like, oh, it can do 600,000 transactions per second, but most of these transactions are votes. So like I think ballpark of this number is approximately right. Well, it could be debate of exact numbers, but you can see that like not all blockchains are the same in terms of their transaction per second performance. Like some of the blockchains are more scalable. But I think this is a wrong chart, because for Web3 to really succeed, we should compare ourselves not to some other blockchains. We should compare ourselves to the world and to infrastructure we're trying to replace. And if you start comparing with those, I'll make another chart, for example, to Twitter that has 5 million requests per second. You see that all blockchains are dwarfed by that. So like we don't have blockchain technology that allows people to build application as of planetary scale, like Twitter, Facebook, like Google Docs, and others that has millions and millions of users per day. So that's this type of thinking was behind of creation of IPC. Again, it stands for Interplanetary Consensus. And the way we see IPC is like, I'll read it out, is new decentralized trusted transaction fabric that breaks limit of traditional blockchains and enables planetary scale Web3 dApps like social networks, multiplayer games, AI data science, and productivity, and accommodates Web2 volumes, throughputs, and latencies, and scale in lockstep with projected web growth. So I'll unpack it a little bit. So IPC obviously decentralized because it's blockchain, trustless, yes, because like you can join IPC subnets as a validator, as a user, without anybody's permission. There is and also you don't have to trust any particular provider, because the network can be distributed between a bunch of validators, no particular validators have a full control. When you say transactional fabric, so what we mean by that is that if you see Web3 architecture as a set of services, then it needs some form of communication protocol that can connect them with each other. So that's why we see transactional fabric is like, it's this glue that combines all the services together. Yeah, and I was mentioning that we want to make Web3 to the level of scale of Web2, and I think this is a way how Web3 can get mass adoption, because if you build a successful service that can serve millions of people and become a household name. Yeah, and when we start breaking down scalability into throughput, yeah, like we need millions and billions transactions per second, and latency sub-second. Like if you're serving some UI related UI related workloads, then you want their pages and your applications to show responses like instantly or near instantly. Okay, so the next section of the workshop, we will go through a few cases and like features of IPC, and I will try to explain how it works. And let's start talking about what IPC really is. And IPC creates this recursive tree of subchains. So imagine you have mainnet, let's say L1 is Filecoin, and you can start spinning off side chains. We call them also subnets. And there's no difference really. So the reason why we use the term sidechain, because sidechain is a common term in the industry. But because IPC sidechains form this tree-shaped structure, when you can spin off child chains from a parent chains, we can say the subchains. In this case, like L2 gaming subnet here, like would be subchain of L1, and game A could be subchain of this gaming subnet. So, and looking at this picture, you can see that there is it's a different worldview on how you build your applications. So the traditional mental model for building Web3 applications, as you deploy a bunch of smart contracts in some form of chain, and then you create a front-end layer or business logic layer somewhere in a centralized service like AWS, and you call it a day. So we propose here a little bit a different architecture when you can split your application in multiple subchains, and it creates a set of advantages for you as a developer, and we'll talk about them a little bit later. But what's important to see that when you think about IPC, you don't think about one particular chain. You see the whole architecture of additional subchains, and application can be split between multiple chains. There is a question: is IPC part of Filecoin? Isn't Filecoin achieve consensus for data stored in Filecoin? Yeah, I think IPC is technically it's a separate project from Filecoin, but the first focus of IPC is to help Filecoin to scale. And if you think about Filecoin, you can think about Filecoin mainnet as a place where you can post and validate Filecoin deals. But also with the launch of FVM, which is the topic of this hackathon, Filecoin acquired programmatic capabilities. So you can think of IPC in this context as a way to scale FVM applications, right? Like, for example, if you start building on mainnet and you are completely satisfied with latencies, like 30 seconds for the block and like 7.5 hours for finality, and you're satisfied with throughput that Filecoin mainnet provides, then there is no problem. You can continue doing this. We spoke with a bunch of developers, and they were curious, like, oh, how can we accelerate it, or how can we reduce the gas price, because we want to build applications that processes like thousands and thousands of transactions per day, and we don't want to pay gas prices for those. And And so IPC can be an answer for these use cases. So IPC, just to summarize, long answer, IPC is not a part of Filecoin, but it can help Filecoin to scale, and specifically FVM applications that have more demanding workloads. We think they can highly benefit to IPC. Matthias, I hope I pronounced the name right. Say in this case, subchain sounds like microservice architecture. I'm not a big proponent of microservice architecture, but I can see similarities, right? Like when instead of building monolith, you split application in a multiple parts. I think for IPC, you can there is very concrete set of reasons why you do it. It's and I'll talk about it a little bit later. I don't want to kind of to create many spoilers because I have a separate slides. But yeah, like you are split one big thing into multiple things, and in this sense, I think there is some similarities with microservices. Yes, and Iman asking about security mechanism. I think it's great question. Hold on to it because I will be talking about it very soon. Okay, so the first is actually my slide is related to this microservices question. So let's talk about examples that I have on the slide. So let's say you have mainnet and you have gaming subnet. And gaming subnet is a special L2 that like multiple participants run together to provide infrastructure specifically for gaming. And when you build a game, you can create your own subnet because, like, for example, you want to manage more data than it's economically and technically feasible to put on gaming subnet L2. Let's say you have a lot of data, you want to store it on a chain, so you can spin out the chain specifically for your game, and it will be essentially the only application there. When you think about the user may have identity in any of these chains, right? User will have identity to mainnet, so the user will have identity on gaming subnet L2, and will have identity in game A and in some of the regional subnets for this particular game. So user is everywhere, but like usually the path they will take to interact with your applications, they will, let's say they buy some coins on L1, or if your token is hosted on L2, you can buy them on L2. And then you have to transfer them to participate in the game. But then they can transfer the coins out if for example, they buy some asset and they can transfer back to L2 and L1, and so they can transfer freely between subnets, but their identity is separate. What is interesting, so I think there's two interesting lessons in this diagram. One is that you can create your own subchain specifically for your application, and in this subchain you can define your own rules and change how the stack works. Maybe you have certain preferences in terms of which consensus mechanisms run in this is used in this subchain, or for example, you can decide to put all the nodes of your some of the subchains in certain region. And if like when you play some of the games, for example, like Call of Duty or like Minecraft or others, you can, or Fortnite, it connects you to the server in your local geography to reduce latencies. So we can take some node from this technique and create subchains that is local for particular geography or even local for particular data center. And it provides huge advantages in terms of latencies, because if your consensus mechanism runs between nodes distributed geography with a longer delays, it will slow down the whole consensus mechanism sometimes in orders of magnitude. But the most important takeaway here is that like your app can span multiple chains. Okay. So I started this presentation with a question of scalability, right? Like I was comparing throughputs of blockchains to Twitter, and the question was like, okay, like you guys propose IPC, what is your scalability story? I think scalability story is really simple, right? If you split your application or you use a whole infrastructure in many subnets, all the subnets run consensus protocol in parallel. So if you're inside of your, let's say, inside of your subchain, let's say it's game A, and consensus mechanism of this subchain doesn't depend on what's going on in mainnet. If mainnet is slow, you don't care, right? Like you will be publishing some checkpoints, and we will talk about checkpoints a little bit later. But you can publish checkpoints periodically, and it may be some delay when these checkpoints are accepted to mainnet. But your experience is not affected, right? Like, and D5 subnet L2 here doesn't affect your like gaming server in Asia Pacific. It's completely two kind of different parallel set of kind of nodes and infrastructure. So we achieve horizontal scalability by spinning out as many chains as needed. And in this sense, you can get, by adding computers, that's what essentially horizontal scalability is, you can parallelize your workloads. The question is, can we get slides for presentation? Saksham, do you mean right now, or you mean after? Yeah, after. I can try to get the slides out. I use a new presentation software called Pitch, and I don't really know how to export yet, but I will try. Okay. If this is the only question, I can share public URL with Pitch. Okay, cool. I'll share the URL. That's okay. Let's talk about checkpointing. Cherif, you asking how long can the block time can get if you create an IPC subnet? And so it's my favorite question, and as you may expect it will be answered later in the slides, because I wanted to talk about it myself. So let's talk about security and checkpointing. So checkpointing is a mechanism when you create a Merkle tree of the state of your subnet, including like all balances and all states of your smart contracts, and you can add it to the state of your parent chain. It's in a way very similar to how L2 rollups in Ethereum works, but there is one big difference, and I'll tell you about it. So when you create a subnet, you can select the checkpointing interval. So it's how often your checkpoints, which include the link to Merkle tree of your state, plus all transactions that you want to publish on your parent chain, it all included in the checkpoint. So, for example, if you checkpoint once a minute, then one of your validators will take a state of your subnet, and all transactions that need to be pushed to your parent chain and submitted to the parent chain. And the benefit of this is that by keeping history of this checkpoint in the parent subnet, you can roll back the state of your child chain in case something happens. For example, let's say something is happening in gaming subnets. So there is some misbehavior, some malicious activity happening. The chain was taken over by somebody else. You can always restart this chain from any checkpoint because you have the full Merkle tree, and recreate the chain and keep all of the state that you had. So in this case, the amount of damage that can be done to the data of your chain is limited to is limited to the time between checkpoints. You can choose checkpoints that you think is valid and restart your subchain. So and And the new sanitized subnet hopefully will have a better governance and will be prevented from having the same type of problems. So you can use initial checkpoint as a genesis block. And this feature applies recursively between any subnets. So like if there is problem in North America, and then game A can restart North America subchain with a different set of nodes based on the genesis, using checkpoint as a genesis block. Okay, keep going. So the next property is that I call security firewall. It is similar to checkpointing, but it alludes to the feature that subnets are separate, right? So if something happening within subnet, the maximum damage it can do is with information within subnet, right? Because each of the parent chains have an independent consensus protocol, and it can accept transaction from the subnet if they are valid. But in case you took over subnet or the data is damaged or anything that happens, it doesn't trickle down to the whole system, right? Like, so that's why in a distributed architecture, having a tree of subchains is a more robust approach because you can always localize the damage. Okay. Custom subnets. So when you start building this planetary scale applications, you may have different requirements, right? If you building application that is specific to computational workloads, you may have different requirements for your stack that, let's say, you have a data intensive, or you want to create subnet specifically for DeFi applications that it needs to be super secure. So you can choose a lot of features of your particular stack. So when you create a subchain, you can choose your consensus protocol. Like if you like Tendermint, you can use Tendermint. If you like some other variety of BFT, they can use BFT. You can use proof of work if you want to. So there is no particular limitation on the consensus protocol within the subnet that is included by IPC itself. But the default implementation use BFT proof of stake, like one of the classic algorithms. So there is nothing crazy going on there. But the architecture itself allows you to customize your consensus protocol. That's the first idea. The second idea, that actually you can change what is your stack. For example, if your gaming subnet, let's say it's use EVM, you can create subnets that use different language. You can have your own WASM virtual machine, and it doesn't. There is no limit on your execution environment as long as the protocol that defines the contract between child subnet and parent subnet is intact. So you can imagine you can create subnets that is really optimized to run to store structural data. So you can call it database subnet, or there is a specific subnet that is really good for real time for games, or you can have subnet for AI inferences, or a lot of other applications that you can imagine. So the ability to customize the stack is kind of central for IPC. And we think it will be really important once we support a wider variety of use cases. Okay, yeah. And people were asking questions about finality time and block times. So block times really depend on two things. It depends on the consensus protocol, on number of nodes, and how close the nodes are together. So, and we see different numbers that are possible. Like if you build mainnet with a planetary scale, I think you will have consensus time in terms of seconds at least. Some of them have minutes, but like more modern protocols, with more modern protocols, I think it's feasible to achieve consensus in a matter of few seconds. If you need sub-second latency times, you can place your nodes in one geographic region, and we have already projects on the platforms that trying to use this particular feature to their advantage. For example, when we're working with AI inference stack, they ask us to have very low overhead on the side of the protocol. So they want to place nodes and serve clients in a particular subnet that are designated to a specific geographic region. And data center level subnets, I think it's a more exotic topic, but we expect that in specific high performance scenarios, when all nodes in the same of the data center, it comes with security downsides, right? Because like if something happens to this data center, your data is essentially gone. But the benefit of that, you can still run decentralized blockchain with very, very low latency. And I think it's great for some of the application. So Iman is asking, is there max length depth for this tree? So theoretically, no, there is no depth. There is no maximum depth. You can go to L100 if you want to. There is issue, and I think it will be in the next slide when we talk about like transfers. And it's not like perfect architecture that they can handle anything without if you use it without thinking, because with every hierarchy you can have bottlenecks on the parent nodes. So like if you want data center C here speak to Asia, they will need to go through mainnet, and the delay could be significant. So you need to think creatively how to design the architecture of your subnet, but and that's probably more realistic limitation of the length and depth of the tree rather than just simple like on protocol level you can go as low as you want. Rory, I think we're at time. I have a few more slides. Do you have any advice? Should I kind of rush through them? Should I stop right now? Any good suggestions here?
I mean, if you're happy to carry on, then feel free to rush through those quickly. Also, for all the questions in the chat, we can direct those to the Discord channels for afterwards. So yeah, if you're in a rush and just want to
no, I'm not in a rush. I can stand. I can stay maybe for a few more minutes, like for sure, like maybe. But let's try to wrap it in 10. And guys, feel free to drop off if you have somewhere to be.
Great, thank you.
So I'll want to illustrate a case of cross subnet communication. So like the question is like, okay, I am in North America. I want to talk to game C. How would I do it? Like you do it through the hierarchy, as I was mentioning, right? Like North America needs to talk to game A. Do you guys see my? Or can you see my mouse here?
Yeah, I can see.
Yeah, cool. Yeah, North America can talk to game A. Game A can talk to gaming subnet, and gaming subnet can talk to game C. And or you, if you want to do some, like let's say you want to talk, you change your coin in DEX that connected to DeFi subnet, then you will have to traverse the whole hierarchy through mainnet. So currently, this is how cross-net communication is handled. We're thinking about more of parallel path to communicate between subnet, but it's still in design phase. So right now, you need to go through hierarchy, and this gives you a hint that it is probably the biggest bottleneck so far for IPC, because you're limited by the speed of the parent subnet. Let me look at the questions. Nikos has a question: how different is IPC from Ethereum rollups? It's a really good question. Like when I joined the team, that's for the first thing I was asking, and it took me a while to figure this out. So I think IPC, the closest metaphor in Ethereum world to IPC is a plasma chain. So if you think about, like, there is this two dimensions of, like, if you think about Ethereum scaling solutions, there is two dimensions. Like the first is how do you solve your data availability, and second, like, do you use ZK or not? So, and if you use your parent net for data availability, essentially you publish summary of all your transactions within your subnet on your parent as a call data, then you have a rollup, right? Because rollups, they use your parent net for data availability. If you use something else called Plasma, and that's what IPC is using. And this is deliberate choice because, like, if you use your parent subnet for data availability, it's a clear bottleneck for your scalability. Like, you cannot run millions of transactions per second and publish them all in your mainnet. Your mainnet is not going to withstand this type of load. So IPC use in its in this kind of default architecture, it's more similar to Plasma. So if you want to slash on a parent, and if you for security, you will have to kind of solve your data availability problems separately by, for example, running a full node. That's what's recommended. So if you want to be a slasher, you set up a full node, you receive all transactions, and then if you think one of the nodes misbehaves, you can get a proof and put it on a parent subnet and slash it because it's a proof of stake chain. So, and the second dimension is whether people using ZK. Like, current implementation doesn't use ZK, but I think IPC is actively exploring how we can use ZK stack to improve our kind of security and privacy. So stay tuned for updates in this area. What's the potential difference between Polkadot parachains and IPC? I need to take it back these questions because, like, I'm not a big, like, I don't know Polkadot that well. I know some of them, our team members were researching what's the difference. So I will take this question offline. Sorry, like, I know a little bit more about Ethereum. Show please in other slides. Okay. So this is the part that I will skip, and I thought, like, okay, if we have a little bit more time, I can talk about the internal architecture. Okay, let's do it like 1 minute version. So in each subnet, you have there is 3 elements of IPC. One is IPC agents. So it's a process that forwards information between chains, and there is 2 smart contracts. There is a gateway actor and subnet actor. And subnet actor created in a parent chain for every subnet. So, like, if you have a subchain A, subchain B, each of them have subnet actor within the parent chain. And gateway actor is essentially an interface between subnets from the child subnet to the parent subnet, and it allows you to create checkpoints and accumulate messages for forwarding into parent subnet. So IPC agent is forwarding this message between chains, because if you have child chain and rootnet, there is no direct line of communication. There is no, like, calls that the child subnet can make to the parent net, but IPC agent does it. It's actively pulling the subnet state and forward it between chains. It's more on detail described in IPC paper. I can share it in the Discord maybe sometime later. So I think that's important slide about IPC roadmap. So we currently in alpha, and we are launching beta in a few weeks. So we will be announcing alpha and beta. There is a big difference between that, because alpha made with a different stack. So the alpha was made with a Lotus, which is Filecoin mining client, and beta is made with standard mint. It's completely a rewrite of the IPC. Even I think it will be more clean, more robust implementation, and we will go with this implementation to official launch on mainnet, and it will be sometime by the end of the year. There is a description of Filecoin Challenges. Essentially, like, I'll go really quick about it. Like, you can if you build applications that leverage improved finality, like latencies and throughput, please do. Subnet tools, we're always looking for subnet tools. I think IPC is very much bare bones right now. We have the main protocol stack, and that's it. If you want to build, like, something related to subnet management or analytics, or let's say blockchain explorer, please do it. I think it's a great topic to discover. And another thing is multi-subnet wallets. If you saw the diagram, IPC has, like, to cross subnet communication is multi-hop, It means that user has to be in multiple subnets, but it may be not the best experience with existing wallets like MetaMask, right? Like if you have to switch subnet every time, like, oh, I'm in a gaming subnet, I go to game A and again to North America, MetaMask would have to switch endpoint every time. So if you can think about architecture, how to build a wallet that is more seamlessly in multiple subnets at the same time, and doesn't make a big deal out of the switch, that's an interesting avenue to explore. And I think we're getting to the Q&A section, and we have the whole minute. And somebody asking me, Nikos, is can you please answer Sharif's question about building your own subchain? Oh, is it feasible to create your own custom IPC in 3 weeks? Is there a list of open source IPCs? I don't really understand the question. So IPC is a stack. IPC is a way to create your own subchain. So you take essentially the way you work with it. You take this open source stack, you download it to your machine. You configure it, and in a certain way, and you can. There is a command to create your own subchain, and it essentially creates a subnet agent in your parent subchain, installs it, initialize it, and then you are free to add validator nodes to your subnet. And once you start configure your validator nodes, you can start mining and your create API gateways, and your subnet goes live. And the video that explains how to do it will be published. So you can create your own IPC subchain not in 3 weeks. You can create it in a day. If you're asking about can you create your own custom stack, like that depends, right? Like if you get into the internals of the IPC, it may be difficult to debug, but we know at least 2 teams that took the alpha implementation of IPC apart, installed different virtual machine, for example, for WASM and for other execution environments. They did like some hard surgery. So it depends. But for the way how we intended to be used in this hackathon, you need just to create your own chain or multiple subchains based on IPC. IPC will be a framework, but the parent network should be probably for hackathon calibration from Filecoin, and you can move forward developing and deploying your smart contracts. Can you provide a link for getting started with sidechains? Yes. So I will share a bunch of links. I think, Rory, it might be better to do it in Discord because this chat will go away, right?
Yeah, of course. So as you say, you could share it now, but obviously we do have the dedicated zones on Discord. So as you say, it might be better to share it there so people have it.
I'll share it on Discord. I think it will. I will share a link to the slide. I will share a link to the guide how to create your own subnet in a text that is available on GitHub. And also my team is working on the video to explain this step by step. So it will be even better than doing a live workshop. Okay, cool. Thanks, everyone. I will be on Discord in the next few days, maybe mostly before September 7th. Then I will share all information. So if you're working with IPC, there is a Slack channel, IPC Help, where all our team is answering questions. I think that's the most important source of information. If you have any questions, going to Slack would be the best way. We will try to be on Discord, but it's a little bit less monitored because it's an event server, but IPC Help is forever channel for everyone to ask questions.
Of course, yeah. And Mikhail, again, if you could share a link to that Slack, hopefully people can be redirected.
I will share a link to Slack on Discord, cool. not the other way around.
Perfect. Brilliant. Well, yeah, on behalf of everybody, I think for the last session of 4, it is amazing to see how engaged everybody was. So that's a credit to Michael. Thank you very much for the session. I think you asked me not to jinx the session beforehand, but hopefully you felt that went smoothly. So yeah, thank you very much to all of the participants. We do have another event tomorrow at 4 p.m. BST. It will be a workshop with Lighthouse, and all of the details will be shared with you shortly, calendar invites and links. So yeah, if you enjoyed today, please do join us again tomorrow for more of the same. So for one last time.
Is there a recording of this?
Yes, of course. And yeah, as always, the recording will be shared in the resources channel on Discord. And Mikhail, I can send one directly to you as well. So
Right.
Brilliant. Well, one last time, thank you very much. And we hope to see you all again tomorrow.